Cool. All right, I want you guys to find the teacher example for the cation that we did last week. And last week, the one that we were looking at as our example was the lead ion. So that's what I want you to find. Yeah, they're all at the front there. So find your lead write-up that we did with the teacher example. Yeah, grab as many as you want. Yeah, there's more template papers at the front if you've lost it. All right. So, using our success criteria, again, just to double check what we need for the assessment. Remember, everything that's written in red is the achieved. Basically, this first sheet is everything you need to do for the achieved. Yellow, I put as just my processing, just so you guys can see how I'm trying to work things out. And then today we're going to go through the merit and excellence level requirement. So, some things to keep in mind with the assessment requirements. The first thing I need to be able to do is identify an unknown ionic compound by carrying out an experiment. So the first thing you need to be able to do to pass is to get the right ion. If you get an incorrect ion, then it automatically marks to not achieve because you haven't done the practical process correctly. So we figured that out was lead, so I'm going to tick this off. I'm just going to do multiple ticks in the same box just to kind of go through each example. The other thing you need to do for the achieved is stating all your observations. So I'm looking to see, do you have your experimental steps done? I'm looking to see, have you told me what happens when you mix those two things together? So we did that on Friday. And the last thing I need to do is identify all the precipitates. You can't do this until you figure out your unknown ion, because I need to know what the cation is, because that's half of my precipitate that has formed. So you're going to do that at the end and go through and add that information. So since I figured out that was lead, when I look here at this sample and I added sulfuric acid, the sulfate is going to be my anion in that case. So since I have a cation and an anion, lead sulfate is my precipitate in that first example. Are we good so far? All right, and then I do that work for the other ones that I saw with the white precipitate. This one's really easy because it's just the sodium hydroxide, and so that's lead hydroxide. Be mindful, for your own safety, I would suggest running both the word and the symbolic equation when it comes to your identification, because if you make a mistake like this, PbOH, and you do that, or let's say you do PbOH2, I would mark both of those as incorrect, and I wouldn't be able to give you the achieve because you hadn't written down the word form. So if you make a mistake here, but you do have the word form, I can pass you on it. So do both just as a safety measure. Cool. The other one that can be a little bit tricky is the one with the 2 drops of ammonia. Remember, ammonia is a weak base, so it actually is providing us hydroxide ions. And so the precipitate here is going to have the hydroxide again. So basically, whatever you have up here is going to be repeated down here. So just watch out for that one. And that's going to be consistent. It's throughout the cation identification steps. You're going to have the 2 drops of ammonia and then excess, and you have to be able to tell me what that precipitate is. Cool. And then if I tick that off, that is my achieved. Can I move on? I see some people that were like scribbling because they don't have this copy done from the other day or were absent. Is it okay if I go to the next bit? Okay. So next thing I need to do for the merit then is I need to link my observations and explain the process of my identification. So this is where we're starting to do our justification components. So step by step, let's look at what we've done stepwise and then use that to my justification. So first off, with my justification, I notice a white precipitate forms, and I've added hydroxides. So if I'm looking at my solubility rules, I know that all hydroxides are insoluble. So not surprised that I got a white precipitate because of that, with the exception of those in group 1 and ammonia. So that tells me I can rule out anything from group 1 and I can also rule out ammonia as well. So that's what I'll use in my justification. Precipitate forms because all hydroxides are insoluble except group 1 and ammonia. So therefore it's not, from that information, looking at my flow chart, it's not NH4 and it's not Na. Precipitate is white. PPT is also white. So could be, and let's look at our list of our white precipitates: aluminium, zinc, lead, magnesium, or barium. Are we good so far? Now, while you guys are doing this assessment, it's up to you what order you want to do it in. Maybe you want to do step 1 first and then justify step 1. Maybe you want to do all of the achieve stuff first and then go back and do your justifications. It's really up to you. Are we good so far? All right, step number 2, to the same test tube, you add excess sodium hydroxide, and what you notice is that the white precipitate disappeared and the solution is now colorless. This justification is explaining that a complex ion has formed, and so that is now going up to the excellence level. If you don't do this justification, then you're not getting up to the excellence level, and that's okay, you're still going to be at merit. So this next step here, the PPP disappeared. Because a complex ion formed when excess OH minus was added. Which is soluble. So that's actually an excellence level assessment. If you leave that blank and you don't want to explain why it's being dissolved, then you're only going to get to the merit. Right, we good so far? Right, next one here is number 3. Number 3 says a new sample. I'm just going to actually fold this so you guys can see it as we're going. A new sample with my unknown is added. I add 2 drops and a white precipitate forms. So in this case, I need to be mindful that I am justifying why there's a precipitate forming. So I would start off with saying that ammonia, NH3, is a weak base. Therefore, provides OH minus. Since all hydroxides are insoluble, precipitate forms. So I'm just going to go through and do all my justifications because I find that's easier. Keep going. Okay. Now, what I look at for step number 4, I'm just going to fold this over so you guys can see step number 4. Lining up. To the same sample, we added excess ammonia, but the precipitate remains. So again, this is now looking at our complex ion information, and this is going to go up to the excellence level if I want to explain what's going on here. So, even though excess NH3 was added, the PPPT remained because this ion cannot form a complex ion with NH3. Even though excess NH3 was added, PPP remain because this ion cannot form a complex ion with NH3, thus remaining insoluble. Cool. So that's, again, like I said, a green level thing, because now we're looking at explaining what's going on with the complex ions. Cool? All right. Last thing that we then have, what that does tell us is that it's not, therefore it's not zinc 2+. So it's either aluminium or lead. From that information. I should add that up here. Therefore, not Mg2+ or Ba2+, can be zinc, aluminium, or what was the last one? Lead. Because all of those can form complex ions. So I'm just adding some extra level of details just to show that you are certain what you're doing and why. Cool. All right, last one. We have a new sample, and with that new sample, I have a white precipitate forms. So precipitate forms, confirming unknown is Pb2+, because all sulfates are soluble except if it has lead. And if you want to put an extra note just to make sure, you could say that silver sulfate, or sorry, not silver sulfate, aluminum sulfate would be soluble. You just want to add an extra layer to show that you know what you're doing. Cool. Questions, concerns, comments? I'll leave that up. I just want to quickly talk about the assessment requirements. So we've done all the achieved. We've linked the observations to explain the process of your identification, and we've explained the results using the solubility rules. Now we have to do is just balance our equations. Yeah, the only other thing I would add is saying that you know that this is, the colors. So white precipitate. This one up here, white precipitate. That would be the only thing I would add. Should have added colors. Cool. All right, keep going. All right, equation time. Yes? Okay. For the equation, to make your lives easy, look at your sheet to see what you have identified as your precipitates and just use that and work backwards. So for that first reaction, I've identified as lead hydroxide. So start with PbOH2, that is my solid, and work your way backwards to include the two ions. So I'd include the lead, and I would include the hydroxides. Make sure they are balanced. So there's two hydroxides here, two needs to be on that side. Zoom it up closer. Okay? Yes, no? So, the way I would do it is figure out the product and then work your way backwards. So I wrote the equation. We can actually do it again here because number 3 has the same precipitate. So start with your lead oxide or hydroxide. Draw your arrow and then split it apart into its two ions. So the lead, Pb2+, plus the hydroxide. Since I see there's a 2 behind my hydroxide, when it comes to putting it in equations, I put the 2 in front. And then I personally like to go through and put the symbols in there to show as another way to tie my results. So I'm tying my observations. Because if I say this is my precipitate, I can tell by the equation I know which one I'm talking about for my precipitate. We good so far? All right, last one on the bottom is my lead sulfate. So again, start with your product. Work your way backwards. If you are not sure of the charges for your ions, use your resource sheet and find them. So lead is Pb2+, sulfate is SO4 2-. I don't have to worry about doing any coefficients in the front because it's already balanced. Aqueous, aqueous, solid. So those are all my precipitation reactions. The last thing I need to find then is my complex ion. All right, so for my complex ion, that's step number 2 that we discovered that one. We need to write its equation for it. So we look at our resource sheet, and I'm looking for lead, and I find lead's right here. So again, start with your product. So in this case, I would have PbOH. I would put a 4, because that's what it says on this. On this. I put the square brackets around it. And I put the charge, which is -2. And then just go backwards and fill in the rest of your equation. So I have lead on this side, Pb2+. I have 4 hydroxides on that side. And that's my equation for it. And then I would go aqueous, aqueous, and aqueous. Because it's dissolved. So basically what's happened is we had this substance here. I added some more hydroxides, and that's allowed it to go to complex ion. If I don't have enough hydroxides, it doesn't dissolve. That's why that ratio is really important when you guys are doing your practical. Cool. Right, this last box here, number 4, we don't have to write anything in there because we haven't had anything change. We've had excess ammonia, nothing happened, so there's no complex ion equation I should have there, and there was no new precipitates that had formed. I can still reference the one before. Cool. All right, and that's all you got to do for the practical component of it. Right, what questions do you have? None? Okay. So what I will do is I'll put up 2 more solutions for you guys because I figured I might as well do the practical while we're in class. and you guys can either do the write-ups in class or at home. Sound good? All right.